Activities is displayed on a green panel. Green means go for launch, and it includes, apart from the actors, also the total situation of the launch activity.
Eh bien, nous sommes ici à un petit kilomètre du lancement.
There we are, a kilometre away from the launch vehicle. This is a protected building. It's called Launch Center number 2, CDL number 2, and that's where the center, where we organize all the implementation, the controls, the checks, and the filling in operations before the launch. And this under the responsibility of the COEL, who's going to manage everything. The COEL is the operations manager for all these launches. This evening, for V125 flights, Francis Pellic is going to chair the whole team to head everything. That's true. That's 20 years after L01 that we have flight 125. I wasn't there, but my friends, the pioneers, were here.
And yet, everything had got off to such a bad start. Yes, here we are in front of CDO1, the launch center number 1, where on the 15th of December 1979, we attempted for the first time to launch an Ariane rocket, Ariane L01. And there, after 2.5 months of preparation, we were all struck when, after lighting the engines of the first stage and a few interminable seconds, the launcher failed to take off. It was obvious we were there in front of an aborted launch, the worst thing that could happen to us for the first launch. The worst because all the teams had been so committed to the success of this operation and this launch. Only a little team had prepared this aborted launch, which we had failed to program in less than 189 hours, which out of 192 calendar hours represented 3 hours of margin. However, the state of preparation of this operation was exceptional, outstanding, and it allowed us to keep to the schedule, and on the 23rd of December we were back in the countdown sequence, which beyond all specification had to be suspended because of weather conditions, and eventually it was on the 24th of December that all the efforts and all the willpower of our people were crowned with the success of this first Ariane launch, which was eventually the fruit of all the willingness and conviction of the people working behind it.
It's now 26 minutes to liftoff, and all is green on the status panel for this 10th Ariane space launch in 1999. The third launch in only 18 days and the last launch of the millennium. The fueling of the third stage is being finalized, and the weather report is favorable for the launch. And now some words on the mission.
Yes, we have a launch window of 30 minutes tonight, starting at 9:50 p.m. Kourou time, 0:50 Universal time, and 7:50 p.m. Washington time, to put into a geostationary transfer orbit Galaxy 11, a telecom satellite of 4.5 tons. Its final position over the equator will be 99 degrees west, just over Galapagos Islands. It will have 2 footprints, one C-band over continental United States, and one K-band all over the Americas.
We have 2 seasoned space companies here tonight. PanamSat, the world's leading commercial provider of satellite telecommunications, with 19 satellites in orbit. The venture started in 1988 with a PAS-1 launch on Ariane 401. Robert Bednarek, that was here then, he's also here today in the front seat as mission director. PanamSat is entering a new phase of expansion with the launch tonight. A further 6 satellites are scheduled to be launched within the next 15 months. Hughes, the world's leading manufacturer of communication satellites, will provide the satellites. 2 will be 702s, the same as the payload tonight, and 4 will be HS-61 high-power satellites. Hughes Space & Com has built nearly 40% of the commercial communication satellites now in orbit. And here is a PanamSat presentation.
The airwaves are alive with intelligent connections that encircle our planet. Soon, PanamSat will have the largest geosynchronous satellite system in orbit, and customers the world over will be wired into the future as never before in history. The 1950s, so different in television terms that it may as well be the Stone Age. Today, television is being reborn as PanamSat satellites beam down the images and sounds of countless worlds to hundreds of millions of people in over 70 countries. Satellite communications are transforming the way business serves the needs of its customers. The fast pace of business and everyday commerce, such as rapid approval of credit card purchases at the gas pump, depend on satellite communication at extraordinary speeds. Global businesses are awash in a sea of information. PanamSat is helping to make infinite amounts of knowledge instantly available and enabling businesses, industries, and individuals to zero in on the data they need. No recent technology has transformed more lives and more businesses than the Internet. PanamSat satellites are creating distribution networks, driving the exchange of information, entertainment, and services from one-to-one to one-to-many. Satellites are driving the process of convergence, creating a world in which we shop, invest, interact, and are entertained through a screen that is linked by a satellite. The men and women of PanamSat are working around the clock helping to shape this world, bringing to many information and entertainment that once seemed available for the few, and making extraordinary possibilities a reality.
The third world-leading space company here today is, of course, Ariane Space, that since its start with Flight 9 in 1984 has launched 165 satellites. Around 65% of telecommunications satellites operating today have been launched by Ariane Space. We'll talk about these three eminent companies a bit later on. A significant representative here is the successful venture in the Galaxy 6 satellite. And the satellite project manager of PanamSat, Brian Singh, will tell us about the launch company.
Here we have Galaxy 11 arriving on the Antonov, the largest aircraft of its kind in the world, the large container. Here the satellite is being prepared for spacecraft testing, and the engineers will do all the testing. Transportation of the satellite using the CSG transportation container to go over to the fueling hall, which will fuel the spacecraft. We transport at night for temperature reasons, bring it into the airlock. Here the Hughes aircraft propulsion engineers and technicians load the spacecraft fuel for the satellite. Here, final readiness of the satellite and the mating of the spacecraft to the Ariane adapter. Bringing the two halves of the fairing together, putting on the logo, the PanamSat spot logo, transporting at night to the pad. Here we have the crane bringing it up. Mating of the satellite to the Ariane rocket, and finalizing all the hardware. And there we are. We're ready for launch.
A leading star of the PanamSat venture is, of course, the dog Spot, a cartoon character that René Anselmo used as his alter ego in his fight for a satellite transmission license in the mid-80s. And he has been with us on the fairing since Flight 65 in 1994.
Yes, but he didn't look like that then.
Oh, you're right. He had a more mischievous image then, which caused some excitement with the co-passenger, the lower one in particular, on logo positioning.
And here we see the Ariane Launch Center number 2, just half a mile off the launcher, with the launch operation manager for this flight, Mr. Francis Pellacoeur. The launch campaign started on November the 20th with the first stage integration. The mechanical integration lasted about 1 week. The launcher was transferred to the launch area on December the 9th. And finally, the payload Galaxy 11 met Ariane on December the 16th.
À J-4, on avait un lanceur complet, 44 ailes et Galaxy 11. La chronologie de remplissage des
The loading chronology scheduled for December the 20 and the final chronology for December the 21.
21 décembre.
The status panel is still green, and we are now 17 minutes from launch. It's been an intense 4 weeks. For the coordination of the activity, and one key person is the mission director of Arianespace.
Yes, the mission director for this flight is Mr. Bruno Gerard. He is a manager from the Operation Directorate, and his role is to be responsible for the general coordination between the launcher, the payload, and the Space Center and its facilities. And here we'll see Bruno making a brief description of tonight's launch vehicle.
Le satellite Galaxy 11, lancé sur 125.
For the payload Galaxy 11, we need the most powerful version of Ariane 4, with 4 liquid strap-on boosters.
Comportant 4 propulseurs d'appoint liquide. Les propulseurs d'appoint liquide.
The liquid strap-on boosters, PAL, are built by Daimler Chrysler Aerospace in Germany, and we have 4 on this version.
Comme le premier étage et le deuxième étage, donc avec moteur Viking.
The first stage is the L220, is built by Aerospatiale in France. It is a storable stages engine technology with 4 engines.
Puisque les ergols sont à température ambiante, contrairement aux ergols cryogéniques.
The second stage, the L33, built by Daimler Chrysler Aerospace in Germany. Again, a storable stages technology stage with 1 Viking engine.
Nous sommes au niveau des bras cryogéniques.
The third stage is the H10. It's the cryogenic stage, and you can see the thermal insulation outside.
L'isolation thermique des réservoirs, dû au fait que les ergols sont cryogéniques, donc très basse température.
The vehicle equipment bay, it is the real brain of the launcher, and it is built by Matra Marconi Space in Toulouse. The nose fairing is built in Switzerland by Contraves, and this flight needs a medium-length fairing.
Donc une coiffe assez importante vu la taille du satellite.
As you heard, the Galaxy 11 takes the whole capacity of an Ariane 44L launch vehicle. The 702 platform is also the satellite of the future with growth potential both in power and mass. Today, the Ariane 5 that was launched a bit more than a week ago is too small for 2 of these 702s. Even a 601 and a 702 together are too big for this. Could you tell me a bit about the evolution of Ariane 5?
Yes, sure. Yeah, as you can see tonight, the spacecraft are getting more and more big and powerful, and Ariane 5 today, as you said, is able to put just 6.5 tons into GTO. However, new upper stages and other minor modifications will increase its performance to meet the demands of the market and make it able in a few years to put more than 11 tons into a geostationary transfer orbit in a dual launch configuration. We'll come back to see the future evolutions in detail later. Now let's see a film about today's Ariane 5 configuration.
Versatile, flexible, powerful.
Attention pour le début de la séquence synchronisée. Top moins 7 minutes. Donc les H0 moins 3 minutes. Correct. Déroulement correct. À tous, du DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage Vulcain. Allumage ERP. Décollage. Propulsion normale. Tous les paramètres sont normaux à bord. Trajectoire normale. All okay on board.
Ready to serve your business.
The launch status is still green. We will have a confirming meteor report in the next few minutes. But in the meantime, there will be some recent news from Ariane space.
I must admit, dear Chairman, that I'm extremely glad, and I can tell you as well, that this is a moment of unequaled emotion. Ignition. Ignition of solid propellant boosters. Liftoff. I would also like to stress how important this moment is for us today. We've gained a competitive edge over all the competition, and we've just launched this launch vehicle, which is now operational. It belongs to the new Ariane 5 generation. Ignition of solid propellant boosters. Liftoff.
The European XMM astronomical satellite was launched the 10th December on the first commercial flight of Ariane 5. Cameras on board of the satellite show deployments and can be viewed on the internet.
Flight 125 is being prepared. It's the 8th launch in 5 months, the 3rd one in 3 weeks. And all the teams working for Ariane Espace, working today on this challenge, are with us, all the industrialists as well, in order to meet the requirements of our international customers. These activities are going to go on till the very beginning of January, and I must admit that the first half of the year is going to be extremely good, as the one we've seen already, with high frequency of launches which meet the international requirements in terms of telecommunications, in terms of scientific issues and application satellites.
The transfer of the Ariane 4 Flight 125 and an Ariane 5 Flight 119 to their launch pads happened on the same day, 9th December, one day before the Ariane 5 flight. Only 7.5 minutes to go, and both the base and the launch vehicle are getting into the final stages of preparation. Could you tell me, Michele, how the Launch Control Center and the Mission Control Center here at Jupiter work together to get to this point?
Yeah, sure. You can compare the launcher to an airplane ready to flight, and the launch operation manager in the Launch Control Center is the pilot of this aircraft. Here, Jupiter Mission Control is the control tower of the spaceport, and we check the readiness of not only the launch vehicle, but also the ground system.
We also have a short map on the weather situation, and it's all go for launch. Please, Michele.
Yes, donc in Jupiter room we have all the system, not only the launcher, the spacecraft, the ground facilities, and the downrange telemetry and radar station.
And 4 o'clock this afternoon, we had the withdrawal of the 3,500-ton heavy gantry. It's pulled away 70 meters to allow the launch vehicle out in the open. But what's been done all the morning to get to this stage, Pierre Michele?
Yeah, the gantry withdrawal is one of the main events in the final chronology. It takes place at about 6 hours before the launch time. At this moment, all the manual operations on the launch area are finished, like the platform opening and all the red flags taken out. Ariane 4 approaches its launch configuration with the 3rd stage loading in the high-pressure vessel pressurization.
À 12 de DDO, attention pour le début de la séquence synchronisée. Top à 0-6 minutes.
So we're now in the stage where the countdown gets too complex for humans to proceed with the launch vehicle, and we therefore have computers working to put the launch vehicle progressively into flight configuration. Could you give me some more details on the synchronized sequence, which is an important part of the launch preparations, Pierre Michele?
Yeah, the synchronized sequence is an automatic program starting at -6 minutes, and in this sequence there is no human intervention, as you said, and the launcher is taken to its final flight configuration. This phase is managed by 2 ground computers in the Ariane Launch Center, one for the electrical system and the other for the fluid and pneumatic ones. During the first minute, we just have the topping out of the 3rd stage, and the 2 computers synchronized together.
The topping up of the 3rd stage, what do you mean, really?
It means that we need to load and load again until the very few minutes. The 3rd stage, which is the cryogenic one, since all the 2 liquids, oxygen and hydrogen, boil and vent all the time, so we need to upload it and top up to have the right level, to have a good level for the liftoff.
Yes, and the procedure, I understand, is done so that you will arrive at a maximum or optimal loading at the liftoff period.
It is an optimal. Each mission has a specified level. And now we had finished this topping up, and we'll see the events as long as they happen. We will have the the third stage pressurization, and after the servo motor starting for the first stage, the launcher arming and the inertial platform unlocking.
And now we're coming up on 3.5 minutes, and that is a time when the satellite has to be on internal power.
Yes.
But
yes.
as we understand it, the satellite already has been on internal power still a couple of minutes before the synchronized sequence.
And we have the pressurization liquid hydrogen tank.
We're going to go through the synchronized sequence in increments to give you the significant points. At the CDL at this point in time, however, what's really happening?
Well, they are just monitoring from all the team. They are no more doing anything actively. They just check everything is okay, and there are the two computers taking all the operation to bring the launcher to its ignition and liftoff.
And it's basically the same also here in Jupiter. The base is ready, the downrange stations are ready, and we're waiting for the final minutes. The cryotechnic arms, what are these?
These are the two interfaces with the third stage. They are used to load the stage with the liquid oxygen, hydrogen, helium for pressurization, and they also have a mechanical function to help the launcher in its position when the gantry is opened and to damp the wind effect.
And how long will they stay on the launch vehicle? When are they released?
They are opened at 5 seconds before the ignition.
So that's basically the last significant point before the ignition starts of the engines?
Yes, it is. We had pressurization liquid oxygen.
So there is 2 minutes left. We are getting closer and closer to liftoff. You can see the launch vehicle out there. There are cameras ready to take the launch through its first sequence in flight. Cameras are there both for you that are viewing, but also high-speed cameras to see how the launch vehicle behaves itself in the first part of the flight. We're coming up on the next significant point before liftoff, which is 1 minute. What happens at 1 minute, really?
At 1 minute, the main event is the switching of all the launcher in its onboard power batteries.
So now that's also closed off from
ground
in the sense of powering.
Yeah.
Top, moins 1 minute.
So we passed another significant event, and the clock is ticking towards the ignition of the engines and the liftoff. And in a few more seconds,
launcher armed.
We are going to leave you together with us and just waiting, feeling the excitement going up the closer we get to the time of ignition and liftoff.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top, allumage,
ignition.
Et décollage.
Liftoff.
Tous les paramètres sont normaux.
You can see the flames will be 8 engines powering the launch vehicle in liftoff.
Yeah.
And it is 580 tons of thrust pushing the launch vehicle up.
Tous les paramètres sont normaux.
It's a bit cloudy tonight. You can still see it going through speed. This is the heaviest launch vehicle. See the fairly slow acceleration in the beginning, but it's rapidly climbing upwards.
Tous les paramètres sont normaux.
must think that we are burning 2 tons of liquid propellant per second.
Per second?
Yeah.
2 tons per second. I wish my car would do that. Not even, I think that's the launch vehicle is spending in a minute what the 747 is doing across the Atlantic from here to Paris.
Yes, but it's much faster as well. And we are hearing the sound here at Jupiter.
When the launch vehicle is passing east of us here. And we are now very close to the sound barrier. It is just after a minute. And
Passage de PD max. Les paramètres sont
maximum
normaux.
Pressure. And the launch vehicle will reach about 9 kilometers altitude. It's a nice night, and it's a bit of cloud, but we can still follow easily the launch vehicle. And I hope all the viewers at the viewing sites, only 4 kilometers from the launch, are really feeling the enormous energy and speed of the launch vehicle when it's going further.
Extinction des pales.
We have now extinction of the liquid boosters.
And the separation.
And we have spent already two-thirds of the propellant so far.
Tous les paramètres sont normaux.
What happens with the separation with the liquid boosters?
The liquid boosters are separated by a pyrotechnical device, and there are a few solid rocket little engines which are slowing them and separating them from the main.
Toutes les pressions foyer sont correctes.
After, another pyrotechnic device cut the tanks. This way they will fall in the ocean, but they are not floating, they sinking. And here we see the CVE, the Visual Immediate Control, station in Kourou, where we receive about 50 telemetry parameter, which can monitor the launcher speed, position, and right trajectory.
And we're closing in on the separation of the first stage.
Extinction L220.
So there you saw also the extension of the first stage, the separation,
Allumage du deuxième étage.
The ignition of the second stage. And you can probably, a bright night like this, also see the separation of the fairing. The launch vehicle is still visible as a point far away on the horizon. On screen you also have the curve, which is described, as Michele said, from the quick look data,
Tous les paramètres
CVI,
sont normaux.
coming on the, being analyzed and put on the screen. We should have fairing separation.
Largage de la coiffe.
Fairing is separated and the launch vehicle is functioning perfectly. The reports coming in are that it's a total normal launch. You can also see on the screen that we've already reached 128 kilometers and 4 kilometers per second.
Les paramètres bord sont stables et normaux.
And all onboard parameters are stable and normal. The first stage, actually, how much of the speed does it give to the launch vehicle of the total speed?
Well, we can think that each one of the 3 stages gives about 1/3 of the total speed needed by the spacecraft to its final position.
And we're then, the final speed we need to reach to get into the right orbit is about 9.5 kilometers per second.
Yes, this is the speed given by the launcher.
And there we have one of the VIPs, Mr. Bird, who is looking happy at what's happening on the screen.
Extinction du L33. Séparation.
And we have also Duncan in picture, watching over the shoulders of the launch team in front of him. And we've had the separation of second and third stage. And we continue to climb up the trajectory.
Yes, all the storable stages of Ariane 4 have finished their mission. Now we are during the third stage, the cryogenic one.
Which is also, although
acquisition par la station de Natal,
has 10 tons and only 1/8 of the first stage thrust, is continuing to increase the speed. We get all of this data from various tracking stations. Here in Kourou, the next one is Natal, which we have in picture, and the Natal station is then sending the information back to Kourou, which it is then taken care of and analyzed at the CVE station. We are now in the longest burn period, about 13 minutes, and we will have some other subjects to talk about when we're here. One, we've spoken about the fairing separation. We have an unusual trajectory tonight. Arianespace and use PanamSat are using the launch vehicle capacity to the maximum. The 4,500 kilograms of the Galaxy 11 satellite gives us some overcapacity. That's being used in two stages. One is to increase the perigee, the lowest point, with about 25% or 50 kilometers. We're also reducing the inclination, which is from 7 to 5 degrees, to get closer to the equatorial plane. And thirdly, we're using as much of the propellant as possible. And then there is a reserve to have a 99% of probability of reaching the exact orbit. We've reused that probability with some small risk of a larger dispersion, but that will give us a higher apogee than foreseen. And that higher apogee can be used then to reduce the time to come into final operational orbit.
Il reste 10 minutes de propulsion.
It should be about up to 1 month, I believe. Everything is continued to work all right. From the excitement, I'm feeling a bit hot, and I'm thinking about the snowball fights here in Kourou.
Snowball fights?
Yes.
Are you joking?
No, it's actually true. And that's back to the early years, 20 years ago, before the first launch, which we saw here on the LO1. There was a fueling model which was put up, and of course you have to take the liquid oxygen out of it. And instead of recovering it, it was put out directly in the atmosphere. And what happened?
I think that you made snow with the humidity of the air.
Yes,
outside.
we made snow, and there was actually a snowball fight here sometime in the middle of 1988.
I see.
Or 1979.
It must be quite an expensive way to make snow.
It is, yes. So we have still going on in the third stage burn. We are at the top of the curve. As Bob Bednarek so nicely explained during a presentation this morning, we are using the gravitational force of the Earth to increase the speed of the third stage. It's optimized and for the best burn or best functioning of the third stage, and therefore the curves looks like this.
Yes, because the third stage, as you told, its main mission is to increase the speed of the launcher and the satellite up to its right speed for separation.
But let's talk about something else than the launch vehicle. I think here we have, it's also fantastic, and the launch is fantastic, but we're having the most prominent three companies, space companies in the world here today. And I think that's really a fitting last launch of the millennium. And we'll start again next year, of course, with the same fitting launch for the new millennium with the same actors.
Acquisition par la station de télémesure d'Ascension.
And we just switch to the downstream station of Ascension.
So that's the Ascension Island. And actually here, Ascension Island is pretty far south of the trajectory. So it's just a short time we're going to see the satellite, and under a pretty low angle as well. So we talked about these three companies, and they're all actually in expansion and moving forward rapidly. We talked about PanamSat, and next year they are replenishing and increasing their fleet. The Galaxy 11 tonight is the first Galaxy satellites to be used over the United States. That's been launched in 3.5 years. So it's a new step forward in improving the services of PanamSat. The international fleet as well of PanamSat satellite is also going to be increased during the 6 launches that's going to be done in the next 15 months.
We have 6 minutes propulsion yet.
So we can continue talking about the next company, which is Hughes, which is now embarking on the new generation satellites. This Galaxy 11 has a number of new features.
Yes, we can see one main feature over its engine, because there is not only a chemical propulsion engine, I think, but also ionic with the gas xenon.
Yes, what's called a XIPS, which is a used minted term for their ion propulsion system. The interesting thing is that the ion propulsion is about 10 times as efficient as chemical propulsion. So you get better use of the propellant you have on board. But what is a drawback of XIPS? Must be something.
I don't know, maybe you can explain me.
Yeah, this thrust, as you have a very light particle, the xenon ions are small and light. You accelerate them quite fast, but therefore the thrust gets very low.
Tous les paramètres à bord sont normaux.
And all parameters on board are still all right. So the xenon thrusters, which are actually much stronger on the 702 than earlier on the 601s, I think about 10 times.
10 times more powerful.
Yeah, and they are using more energy to drive them, but they're mainly suitable for on-station keep the satellite in place. But it can also be used to make the orbit circular from the elliptical transfer orbit.
But this is not the only new technical breakthrough of this new model of satellite, isn't it?
No, it is, or rather the satellite is much bigger than other satellites, and the energy produced by this satellite is around 10 kilowatts, and that generates a bit of heat as well. And the payload, you've got about 60 transponders on board, from 20 watts in C-band up to 140 watts in the K-band.
Il reste 3 minutes de propulsion.
So 3 minutes to go. So this is really the new era of satellites with a growth potential of up to 15 kilowatts and even more in sort of the next generation. And secondly, you have the mass will also be higher. So here again we have something for Ariane Space is to adapt the Ariane 5 launch vehicle to this satellite. And I think you can tell me much more about that than
yes,
we said before.
Just like we said before, we aim to an Ariane 5 which is able to have a dual launch configuration with big telecommunication satellite, which means more than 11 tons in GTO. And to do this, we will have a new upper stage, which is not a storable stage 1, the EPS, but will be a cryotechnic stage. Two cryotechnic stage. The first one, the ECA, will have an engine.
2 minutes de propulsion.
An engine which is very similar to the engine we are using in this moment on Ariane 4. And this normally will be operational by 2002. Later, we'll have a...
Acquisition par la station de télémesure de Libreville.
We are Libreville station.
Quite so we're basically soon over Africa.
So I was talking about the new engine, which will be used on the EAC-B, and this will be ready by 2006. This will be a new cryotechnic engine, which we can reignite. So we'll have the possibility to have a very different separation from one satellite to another with long ballistic phase. And this engine will be able also of a total dual launch configuration of more than 11 tons.
So we'll have to wait a few years downstream, but it's coming. So we have 1 minute left of the propulsion, and I can see Brian Singh and Doug Cowan eagerly waiting for the next event, which is the end of the third stage burn. And everything is still normal. And we should have, if the depletion burn is functioning, we might have some later extinction of the H10.
Encore 20 secondes de propulsion.
So it's 20 seconds left of propulsion. And we should soon be there.
Extinction du troisième étage.
And we have extinction of the third stage. So now the so-called propulsive phase is finished. So what happens now?
So the propulsion of the third stage is finished, but its mission not yet, because the third stage has also
fin de la visibilité normale de la station d'ascension.
The mission to make the attitude control and the right spin for the satellite separation, and this is done by a little system which uses the gas hydrogen with little nozzles venting.
So that's for the whatever the satellite has asked as orientation and positioning of the satellite prior to separation.
Yes, that's it. It is totally controlled by the onboard computer and the flight program which has been charged.
And on the screen you can see the satellite climbing up the trajectory curve, and also you can see that the speed is now going down. As the higher up we go, the speed will go down, and in the apogee the speed will be at lowest, and then it will come back towards the Earth in the next orbit and pick up speed to the 9.7 kilometers again per second. So we're just having a few minutes left before Galaxy 11 is out and free in orbit. I think this is time anyhow to think about the people. Here we're going to celebrate Christmas soon, but you know what happens when the satellite's separated? The Ariane space people, we can go home. We can take the charter back tonight. So I have a very good luck to the use operations people and the PanamSat operations people, which will have to take over the satellite in a few minutes and work it over Christmas and New Year's to get this satellite into its right orbit.
The separation should be in a few seconds.
Séparation Galaxy 11.
And there we are, and it is a successful injection, and you can see the happy faces of Michael Hirschman and Doug Kahn. So now it will take approximately 15 to 20 minutes before the satellite is acquired. So we might know it before this transmission is over. And now, as usual, there are handshakes and people are happy. I can see Hal McDonald there on the back, and he's feeling happy. He's been sitting up front.
2, 1, top, allumage et décollage. Tous les paramètres sont normaux. Paramètres de bord normaux. Et décollage. Tous les paramètres sont normaux. Paramètres de bord normaux.
And the congratulations are still going on. We are waiting a bit. There will be some speeches soon, I suppose. Yeah, people are preparing to go over. And a new T-shirt again. It's always been shirt off and T-shirt on for Doug Kahn walking up here, and I also see that Doug...
Top, allumage et décollage. Tous les paramètres sont normaux. Paramètres de bord normaux.
And also here, I think we should say thank you to the Hughes and PanamSat team that's been here for 4 weeks and working hard to be ready, which they are for Christmas. And I've understood that there has been several first-timers here in the launch team. Now you're veterans, guys. So welcome back in January. Of course, there are some people who like it so much here, so they'll be staying over. Like Rick Laurie, who is going to spend Christmas here in French Guiana. And as you will, I suppose.
Yes. I am spending Christmas and New Year's Day here.
So you may be here then seeing the next PanamSat or the Galaxy 10R satellite coming here just before New Year's Eve, I think, around the 27th, 28th of December.
I think it's a nice way to finish the year. This year started a little bit slow for Arianespace, as you know. We had only performed 2 launches by the end of July. So we decided to set a very ambitious goal to satisfy almost all of our customers. We decided that we needed to launch 8 satellites in 5 months between August and December, which represent the equivalent of 20 launches a year, which we never did. On those 8 launches, 5 were to be performed within 16 days between mid-October and mid-December, which is an equivalent of 30 launches a year. And among those 5, 3 were to be performed in 19 days in December. And that's a fantastic achievement by the team of CNES and the team of Ariane. Not everybody believed that this challenge can be met, I can tell you, within our organization and within CNES organization and within all of our cooperant organizations. So I'd like to thank everybody who made it possible to make this goal a reality by the end of 1999. So that allowed us to satisfy a long-term, faithful company, PanamSat, for which we have launched 14 satellites, 15 by now. And I think it's the best Christmas gift a launcher company can make to offer you a successful launch for Christmas. Now we have decided it's not good enough, and we are preparing a New Year gift because we are going to launch by January 24th another satellite made by Hughes and for PanamSat. Even more, last week we have signed an agreement by which we are preparing an Easter present, and it's a great reward for everybody who have been spending weekends, nights, days for those last 5 months to make all of that possible. So congratulations to all of you, and thanks to the PanamSat people who have been always very confident that we can make it. Thank you.